Example 2 in section 5, we're modeling data by using technology. So here again, we can do Desmos or our calculators, graphing calculators. Okay, so here we have a list of years since their coffee shop's been open and how many shops they have built and made. And so we want to see what kind of growth this is. Is it linear, exponential? Is it quadratic type of growth? So here we can let our year since opening represent our L1 and our number of shops that we have opened, make sure it's L2. So we put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 in our L1. So 14 numbers go in our L1, and then 14 numbers go in our L2. So we list all these numbers, make sure we have 14 in each. And so once all those are in there, then we just need to make sure in order to find out what the regression either line is or regression quadratic might be, because what we want is basically we want our either linear equation or we want our quadratic equation or we want our exponential equation, right? And in order to figure out, in order to predict how many shops might be in the 50th year or something like that. So then we could plug in 50 and for our x and solve how many shops we're going to have in that year, right? So we want to see what type it is by plotting these, just like we did in example number 1. But then we want to come up with an equation that what works best. Okay, so we want to hit catalog, which is down by the 0 button, down by the 0 button. And then we're going to maybe hit alpha D, so then we can skip down to the D's. And so alpha is the green button and D is just 2 down from that. And then we can get to look for diagnostic on, find that, hit enter, it'll bring it up on your blank screen, and then you can hit enter again, and it will say done. So then it's on. Now I can go to the stat button, and now I can enter in all my data, okay, and my L1 and L2. Now I look at that data, make sure you hit your second stat plot, make sure it's on, make sure it's graphing as a scatter plot, make sure your X list is L1 and Y list is L2. Then you can adjust your window, right? So we start out at 0 and go to 40. So we want our X's from 0 to maybe 50. And then we want our Y's, or our L2s, or our list 2, go from 1 to 17,000. So maybe like 1 to 20,000. And maybe you can count by hundreds or you can count by thousands if you want to, something like that. And then maybe years, maybe you want to count by tens or something like that, or fours or fives. Okay, so adjust your window to what you need to, and then you can hit graph, and it's going to pop up like this. Okay, so you can look at this scale. They went from 0 to 50 on their x's and counted by 5, and then on their y's they went from 0 to 20,000 and counted by 2,000. So you could adjust it to that. So this kind of looks like maybe an exponential, but then we notice it kind of maybe evens off down here, so maybe it's going to come back down. So maybe it looks like more like a quadratic. Okay, so if we want to find out what this is called, a regression function, to kind of see what our equation might be. So it kind of looks like a quadratic. So in order to do that, to determine what they are, looks like a quadratic. So we're going to hit the stat button. We're going to move over to calculate. And in here, we're going to go down for a quadratic. I believe that's number 5 on your calculators, but it's a quadratic regression, if we want a quadratic regression. And they actually say this is more exponential because it goes pretty fast this way. So they actually do EXP regression. So they're looking for the exponential equation. Okay, your A and your B, your base B, your A is your coefficient in front. Okay, so they go down on their stat, they go over to calculate, and they go down to where it says EXPREG, which I believe would be the 0, and they hit enter, and then that gives X list. So there you want your L1. Then it has Y list. You want your L2, and then it says frequency list. We don't need anything. Then it has store regression equation. That means we could store this equation. So instead of hitting enter and calculate and getting this a and b that we need to write this equation, and then we have to go back to our y equals and put that in our equation so we can see what this exponential actually graph looks like, and then put in our a and put in our b raised to the x. So put it in these huge decimals, right, is going to take up space and take up a lot of time. So we can store this regression equation by hitting, go down here where it highlights down here, and you're going to hit VARS. VRS is just below the down arrow next to the clear button. So you go down to that and hit VARS, and then you go over to YVARS. YVARS. Okay, and then you want to hit number 1, function. And then you can pick from there, do you want it to be your Y1? Do you want it to be your Y2? Do you want it to be Y3? Most likely Y1. Hit enter, and then I can go down and hit calculate. It'll calculate that. It'll give me what my A is, what my B is, and then, but instead of me writing that down into my Y equals, this store thing will automatically put it there. So then if you click on Y equals, you already have that equation in there. So then you can hit graph, and you can see you have your scatter plot, but then you have this second line that represents that data, that exponential. Then you can go to your table. So second graph, check out that table, and you can look for maybe where the answer is. Okay, what's going to happen in 44 years? How many stores are produced in the 44th year after opening? So then we look at, okay, it is 121,000, right? Or this one, I guess, is looking for year 42 is 70,116, and in year 10 it looks like 10,000. So then we can answer questions based on that. Or I guess that's a decimal, so 10 shops, sorry. Year 10 they have 10, year 42 they have 70 point something, right? Year 44 looks like they have 121 point something. So I can't really see the decimal there. But then you can look and you can estimate, okay, in so many years, what's our Y value, okay?